Namaste, this is Liam in for Ameya. Build it with Claude, then take it apart. Today, a Retrieval Augmented Generation pipeline in PyTorch that answers questions from a PDF the model has never seen and cites the page it used. Ask a language model about your own PDF, a contract, a paper, a policy, and it does one of two things. Says it doesn't know, or worse, invents an answer that sounds right. It never read your document. Retrieval Augmented Generation fixes that. Instead of trusting the model's memory, you hand it the exact passages it needs and make it answer from those. The question this build answers: how do you find the right passages? Start with the index, into Claude, write rag.py, read the PDF, split it into overlapping chunks of a few hundred words, and embed every chunk into a vector with a PyTorch sentence transformer. The overlap matters. It keeps a sentence that straddles two chunks from being cut in half. Here's the real code. Sentence transformers runs on PyTorch, so model.encode gives you a tensor, one row per chunk, 384 numbers each. The one line that matters is the normalize, make every vector length 1, and a dot product between two of them becomes cosine similarity. That trick is what makes retrieval fast in the next step. Run it and the document stops being text. The PDF is sliced into chunks and each chunk lands as a point in a high-dimensional space, shown here in 2. Passages about the same idea sit near each other, unrelated ones drift apart. The meaning of your document is now geometry. An index alone doesn't answer anything. Revise, add retrieval. Embed the question the same way, score it against every chunk with a single matrix multiply, take the top 4, and build a prompt that tells the model to answer only from those passages and to cite them. The revised code, because every vector is unit length, the whole search is one line. Q at mtranspose is the cosine similarity of the question against all chunks at once, and torch.top pulls the 4 closest. Those chunks become the context. The prompt does the rest of the work, answer only from this context, and if it isn't here, say so. That instruction is what stops the hallucination. Now ask a question, it becomes a vector 2 and drops into the same space. The matrix multiply ranks every chunk by nearness, and the top 4 light up, the passages that actually talk about what you asked. Those and only those go to the model. The answer comes back built from your document with the page it came from attached. That citation is the difference between an answer you can check and one you have to trust. So that's RAG end-to-end, chunk, embed, retrieve, ground. PyTorch does the heavy part, turning text into vectors and finding the nearest ones with a single multiply. The model never had to memorize your PDF, it just had to read the 4 passages you handed it. Same model, but now it answers from evidence you can point to. Your turn, point this at PDF you actually care about, Elise, a textbook chapter, a research paper, ask it a real question and check the cited page yourself. Then push on it, raise K and watch the answer get more complete but noisier, or ask something the document doesn't cover and confirm it refuses instead of inventing. That refusal is the whole point. RAG and PyTorch answers from your PDF with the receipt. This is Liam in for Ameya.